Good morning, everybody. My name is Chirag Bansal, and today we will learn about merge sort. Merge sort is a sorting algorithm with time complexity as theta n log n. Therefore, it is an effective way to sort things. It is even better than quick sort, which has a worst case time complexity of theta n square, where this merge sort has a worst case time complexity of 3, 2, 3, 2, 1, start. Good morning. My name is Chirag Bansal and today we will learn about merge sort. Merge sort is a sorting algorithm with time complexity theta n log n, which is an effective way to sort. It is even better than quick sort as its worst case time complexity is theta n log n as well, whereas the worst case time complexity of quick sort is theta n square. So let's look at its algorithm. The algorithm says divide the array into two equal parts, merge sort both of these, and then merge the arrays again. So what do? Suppose we have this array, we divide it into two equal parts, we get two smaller arrays, we merge sort them. The result after merge sort is a sorted array. So we finally get these two as sorted and then we merge them again. Let's look at an example to understand better. Here we have an array 72514389. So according to merge sort, we divide it into two equal parts. Then we have two smaller arrays. Then we divide them further again into two equal parts. Here note that I am saying two equal parts, but if there are an odd number of elements, they might not be equal. There might be a difference of one, but we will still consider them as equivalent. So now we have two smaller arrays and then we divide them and then we merge sort them, which again repeatedly causes it to divide. So we eventually get, after dividing, a lot of arrays of size 1. So what do? And then we start merging them together. We merge them in such a way that the smallest element is kept first, basically in a sorted way. So we merge 7 and 2 to get 2 7, 5 and 1 to get 1 5, 4 and 3 to get 3 4, 8 and 9 to get 8 9, and then we merge them again so that they maintain sorted order. Therefore we get a sorted array of size 4, two sorted arrays of size 4, and then we get finally a sorted array of size 8. This is how merge sort works. So let's look at its complexity. First, let's look at the complexity of merging two lists. Suppose we have these two lists. To merge them, we look at both of the first elements, put the smaller one, and then move the one from which we have took the smaller one to one unit to the right. So we do that till we cover all elements. Thus, we visit each value once. Therefore, the time complexity is order L, L being the total number of elements. Now let's look at the time complexity of merge sort. So when we calculate Tn, where n being the number of elements, we divide it into two equal parts. We try to divide it. If there's a difference of 1, still we'll assume it to be almost equal. So we have Tn by 2, Tn by 2. So to sort them, we take Tn by 2 time, and since we do it twice, the total time taken will be 2n by 2. 2Tn by 2, and then we merge them, and merging takes order n time. So we get this recurrence relation, and then we again reduce it to Tn by 4, and then we reduce it till we get Tn by n, which is basically 1. To get Tn by n, we have to reduce it log n times. Therefore the order n, and whenever we reduce it one step, we have an order n added to it. So therefore order n is happening log n times, and then t1 is happening log n times. So we basically get the final time complexity as order n plus order n log n. As order n is order n log n as well, so the total time complexity will be order n log n. This is how merge sort works and its time complexity.